everybody, my name is Chris Murphy. I work for Epic Games as an Unreal Engine evangelist. My job is helping Australian, New Zealand, and Southeast Asian developers generally. But at the moment, we're doing a pretty big push to start increasing support for this region. And during that period, you all have to deal with me. So I'll be coming up this way more frequently as we kind of like get more developers up and running. And I'll be kind of helping some of those initial like hires that we bring in that are supporting other developers so that we can kind of ease them into everything. Now, quick forward, my apologies to everyone, but you will need to take notes and you'll need to take them reasonably quickly. This presentation is going to be a bit chaotic. I'm not going through it as like programmer tips, artist tips, animation tips. I'm scattered everything. And the reason I scattered everything was actually so that as we power through this presentation, if you're writing down a note, there's less chance of the next slide being relevant to your interests, so you're not so sad if you're still writing down the note from the previous slide. So with that said, let's get going. So the first one is this. If you click Help and then Console Variables, Unreal Engine will actually generate a full list of every single console variable in the game. The reason that's really useful is that you can actually then just search through it. So if you know that you're looking for a console variable with something to do with rendering or fog, you can hit click, generate, and then type in fog. And if you check that little box that says search in help as well, search in help as well means it will actually search the description text, not just the names of the console variables to find it. Now the advantage of generating it rather than just having it in there is that when we generate it, we can also include console commands from your own projects or your own engine changes. So if you've added extra stuff yourself, they'll then be included in that list as well. Next up is the device profile window. So the device profile window is really straightforward. It's a little tricky to read there, but you can essentially override any of the standard variables for different types of devices. So if you open this up, you can go to it and say, hey, on high-end Android, I want to have this setting, but on this specific processor, on this specific device, I want you to take all the settings from Android and override this. And when we provide that in like a nice little packaged like window, it's much easier and friendlier for not just your programming staff to really fine-tune specific devices. Next up, we have the Visual Assist X or ReSharper. I highly recommend using these. They are paid, unfortunately, but Visual Studio can sometimes have a little bit of trouble with the macros that Unreal Engine uses, but VAX and ReSharper are a bit better at allowing you to like jump through code and readdressing things that are referenced in macros. They're quite good. Next up is the content examples, specifically the math hall. So Unreal Engine has a project called the content examples. And the content examples is a listing of like all of the features in the engine that we could into a nice little like bite-sized museum style thing. Now, the math hall is a bit different because the math hall is a level within those content examples. There's actually all of your standard gameplay math. So if you ever want to know how to use vectors, if you ever want to know how abs functions or frac functions or any of those things work, this is a really, really good place because it actually does a great explanation with like real world use cases for all of these common games math functions. I didn't care about math whatsoever when I was in high school. I just did it. And that's because the problems were always things like when will the boat pass the fisherman? And the second it became when will the rocket hit red team, I was paying way more attention. But that wasn't until way after high school. So if you're trying to brush up on some of your basic math for game dev, this is a good place to do it. So if you're in a team that's spinning up and you've just got some new developers coming on board or you've got some artists that are now going to be working with Blueprint, just remember to assign someone in your team that's really able to sit down with them and act as a little bit of guidance and step them through some of the things that are just concerning programming. Because like to be blunt, people look at blueprints and quite often they're like, it's spaghetti. But the truth is that if you can have really ugly code, you can have really ugly C++, you can have really ugly Python, and the truth is that like half the reason we see some of the terrible screenshots of Blueprint that appear on the internet is quite simply that it was someone that had never written code that was trying to get that functionality working. So when you've got someone that's really often providing that little bit of guidance, that little bit of advice, it really helps keep things in check, and then everyone can have a good time. If you hold down the middle mouse button will actually create a little ruler. So whenever you're in an orthographic viewpoint, you really just want to quickly measure the distance between 2 points, just hold down that middle mouse. While we're on the middle mouse topic, Alt middle mouse is fantastic because if you click it, it will create a pivot point at that location and allow you to rotate it from that specific spot. So this is really good for something like this bench. Like if you were setting up benches in a line with a slight curve, you don't want to actually curve them from the middle of the bench. You probably want to curve them from the end of the bench where the last one was and curve it inwards. So in that situation, just Alt middle mouse, drop down that thing, and the second you click off of it, it'll revert to its default pivot point. Control middle mouse will change views. So by this I mean control middle mouse and dragging up, control middle mouse dragging down, control left and control right will switch between different orthographic viewports. If you go down and to the left, that will switch you back to a perspective viewport. But this is a really quick thing to just quickly flick between different viewports and have a lot more control. So when you drag an asset, quite a lot of people, they just drag it and then they chase it with their camera and then they drag it again and then they chase it. Shift drag will sync your camera with the object that you're moving. So as you pull that object around, your camera will lock in place. And when it locks in place, you're going to have a much easier time moving things around because it's not getting kind of stuck and we can just move through it. So control mouse left will move just an object along the x-axis. Control mouse right will move something just along the y-axis. And control left and right at the same time will move them just on the z-axis. By the way, it's really nice following up the previous presentation where he kept saying Z, and I can now revert to the British Z. So take that, America. So, as I said, having that X, Y, and Z axis and being able to control them off of a few clicks, it's quite nice because what we have is we don't have to click on the thing in the middle. Like a lot of people, like you know when you're trying to click on the widget and you just click it off by just a little bit? If you don't need to, just, I know it only saves you the amount of time of doing this, but like, it feels good. Control tilde will change between local and world. So if you can see here, we've got everything in world coordinates, but when we press this button, control tilde, it's going to switch over to local coordinates, which allows you to move it along its own axes, which is just much easier for laying down basic systems. Now, often you control Unreal by holding down right-click and using WASD as the main controls, and then you pilot it like a first-person shooter, right? Now, if you use the scroll wheel while holding right-click and you tap it up or tap it down, it will actually slow you down or speed you up. And this is really good because you tap it up and all of a sudden we're blitzing around the map, and as you get close to where you need to be, you tap it down and you come in for like a nice, smooth, fine, controlled location. And it's just much nicer to control it that way. The next one is if you press End to snap actors to the floor. So they both need to have collision, obviously, but it will literally just get the actor and just drop it down to the floor. And it's just nice, simple quality of life thing. Now, next up is the split perspective. So for split perspective, it's worth noting that you can break the viewport into multiple viewports. And I actually use this a bit when controlling outdoor environments. So whenever I know that a player is going to be walking into an environment and seeing it from a very specific location, the truth is that the location that the player sees it from and the location that's easiest to paint it are often two completely different locations. So being able to kick in like a second window that you're just viewing from while the other one is like being used to paint it can make for a much better experience and just much easier workflow. This topic should be familiar from the previous Q&A, which is blueprint nativization. So again, this will turn blueprint into C++. Now it only happens on build, so this doesn't happen live. But there are two methods you can do. You can either say include all of the blueprints and then choose which ones you want to exclude, if any. Or you can choose exclusive, which allows you to only nativize selected blueprints. So doing that is just kind of one of those things that I genuinely suggest that you use exclusive and you only nativize the ones in particular that you actually want. It's going to make life a little bit easier because not all blueprints, when you enable nativization, will correctly nativize. Sometimes you can do some really weird stuff on the script level that C++ just doesn't respond nicely to, and it'll throw up some errors and you'll need to fix it. So kind of like controlling really just your base classes and stuff like that is often enough of a win. So the landscape grass node, it's a little bit tricky to see here, but that node on the far right-hand side is a grass output. What it actually lets you do is it allows you to flag certain parts of the landscape's environment material and say, hey, whenever something is painted there, I want you to be grass. And you can see here that you can create as many inputs as you want. In this situation, I made grass and I made flowers. And by having different inputs, that texture controls when it's grass and when it's flowers. And what that means is whenever I paint in the grass layer of the landscape, it's automatically painting in the actual grass into the material. So next up, you can use equations for value inputs. So what I mean by this is you can actually type stuff directly into any of these input boxes. And what it's going to do is if you type in like 1 divided by 2, it will just set it to a value of 0.5. This kind of stuff is just really just a useful little quality of life thing. Like if I know that it's this times this or this multiplied by this, or I'm trying to convert from some system that doesn't make sense, imperial, over to metric, that would be, like, again, another really good use case because you can just kind of type in those simple conversions. For folks that are aware of the delay node that we use in Blueprint, if you want to do the same thing in C++, you can just use the timer manager and just spin up a timer handle and create your own. The next one here is Blueprint async action base. This is a nice little thing because what you can essentially do is spin it up such that you can see here that we've got different outputs. What this will do is it'll call it, and then asynchronously it'll start processing it. And while it's processing it, when it's done, it will then call on success or on fail. And in the meantime, it'll immediately flow out of the other top node there. So it's just really nice to just spin something off to asynchronously start to calculate and then return to it when something succeeds or fails. Now, another nice thing that you can do there is expand an enum as an exec. So if you've created an enumeration that has a bunch of different names inside of it, you can actually, inside of the node, call expand enum as execs, and you can see that's there. And what that will actually do is allow you to create different input pins for that Blueprint node that gives you a bit more control for your designers. So sometimes people will create 10 different nodes for something that could be one node with a bunch of different inputs, and that would just be more logical for their use case. And that's really, really powerful. So next up is the editor utility widgets. So editor utility widgets are something that we use these days for. Editor utility widgets allow you to run really simple scripting. So you can run really simple Blueprint scripts that could be things like make sure all patrol units are attached to initial waypoints, or you could set up anything you want on that front. It's really good for kind of organizing your initial data, but it's worth noting that if we look at something like this, you can see that it calls run. You can actually set it up so that it becomes something that's listed in a right-click context menu. So when you right-click on an actor of a certain type, you can declare a function that says, hey, whenever they right-click on pawns, or whenever they right-click on dragons or whatever, give you dragon-specific one-click options to just automatically set those things up in a certain way. Now, this is a really useful little thing that a lot of folks are unaware of. It's a little tricky to read here, but if you have a Blueprint event like this one, and you check the box that says call in editor, so this thing right here, what it actually does is it will automatically generate a button for that event. So this event over here says generate landscape. You can't really read it from there. But by having that, it's then created this button. And that means that the actors in the world, like I could have that button that say something like randomize color. You know, so one time I click it, it randomizes the color and just adds a little bit of variance. And then that's all you need, you know? So having like that kind of like really, really simple stuff is really, really powerful because again, it means that like your designers and your artists can just add really quick, core, singular functionality to certain types of objects that just makes life easier. This is something that I really love, which is that we have a node called draw material to render target. And what draw material to render target does is it gets a material and it creates a texture based on that material, okay? Now, we also have another node called landscape import height map from render target. And what that does is it will automatically grab that render target and push it out as information for a landscape. So in this situation, I've just created a really, really straightforward, simple automatic procedural world generation tool, and it really didn't take much to do it. Now the great thing is that tool in the top right is an editor utility widget, because you can create editor utility widgets with your standard UI setup. So what that means is you can create your own tools really, really simply and provide that information. And in this case, all I'm doing is I'm running Perlin noise into a material, and I'm adding a black spot to kind of like fade it out a little bit wherever I click. And that's all it took to create a really like straightforward procedural generation system that can act as a base layer for any of the things that I add. This is a really cool one. So if you run simulated objects that have physics enabled and you hit simulate and they all fall to the floor, you can click on them all and hit K. And what K does is it will keep the simulation changes. So if they all fell to the floor and you hit K, they will stay on the floor. And this is just a really, really nice way to create like actual realistic clutter instead of like manually placing all of those things, because that's just kind of frustrating, right, as an experience. This is a really useful thing that a lot of folks aren't aware of, but in C++, when you're declaring a U property, you can actually flag instanced. Now what instance will do is it will generate an object that actually gets kind of stored inside of that variable, instead of it creating like, so let's say you had a car, and every car had a wheel class, like 4 separate wheels that was being stored as their own little archetypes. Now you could store those 4 things in the content browser and reference each wheel, right? But quite quickly, if we have a lot of cars, that becomes a really unwieldy mess. So being able to instance those variables means that it will actually just create it and give you like the ability to edit those variables inside of the context of that first thing. This is really, really powerful because like you could do it for wheels, you could do it for level summary objects, like all sorts of stuff. So next up is the content browser search syntax. This is really powerful. It's a little tricky to see from here, but in that search window at the top of the context, actually let me start again. So if you hold your mouse above any asset in, above any asset in the content browser, you can see that we have gray text here, like triangles and vertices and LOD group and all that kind of stuff. So a cool thing you can do is you can actually search any piece of metadata can be searched through the content browser. So in the content browser, I could literally say if the tag is like if the tag has this number, if this value in it, like if it's tagged as foliage, find it. Or I could say if the poly count is greater than 50,000, but the LOD count is fewer than 2, it'll give me a list of every single object with a high poly count that doesn't have many LODs generated already. And this is just a really, really wonderful way to like really just quickly step through the content that you've got in the project and just make sure it's acceptable. And all you need to do to search any of those things is just remove the space. So if there's a space in that search, it won't search it. So you need to, like for LOD group, in that case, it says LOD space group. Just get rid of the space and just write LOD group as one word. Alt-Shift-O is a really powerful thing. This is what we use to quickly open assets. I'm a big fan of this. Basically what happens is the second you hit Alt-Shift-O, you can then just immediately start typing in the name of the asset that you want to open. And what's lovely about that is that like if I know I'm opening the game mode, there's no point me navigating through the entire folder structure just to open up the game mode, right? So if I just hit Alt-Shift-O and just game mode, enter, it'll just then open that class without me having to think about it. It's a little thing, but honestly it does save a bit of time, like every time you go to do it, and it just becomes second nature pretty quick. So this is really great. It's just worth mentioning that the engine has a thing called the Asset Management Framework. So the Asset Manager is a global object that can be used to discover, load, and audit content in the editor or at runtime. Now what's really powerful about this is you can actually flag values as assets registry searchable. You can see it there. And when a value is flagged as asset registry searchable, it will actually add, you can see that it's added that max player count to this metadata. And what's great about that is that I can actually say to the engine, I want to load a level, give me a list of every single level with a max player count of greater than 12. And I can do that without actually maintaining my own secondary lists. I can just access the information. Or I could say to the engine, hey, get me a list of every weapon that does more damage than 100 because they're about to have a boss fight, but I want to randomly select a powerful weapon to give them. You know, like being able to use this information and filter it out is really, really powerful. Now I mentioned editor utility widgets before. I unfortunately had this slide out of order from the previous one because I just reorganized it when I got up on stage. But as I said, this is the just simple drag and drop, so you can really easily just drop in like buttons and widgets and sliders and all that kind of jazz. And you can immediately start laying out your own editor tools without a single line of code. Next up is quite simple. Just generally be careful what you tick for. Tick is a really common thing to use in Unreal. You know, it's like your standard update function for anyone that's unfamiliar with it. However, ticks by themselves generally aren't expensive, but it's very easy to get out of hand with a lot of ticking objects. So in those situations, you really want to consider using timelines, considering using timers, toggling the actor to have tick on or off, or using a polling or an event-driven system to kind of power things. And one useful little console command you can use is called dump ticks. And what dump ticks will do is actually give you a list right now of every single ticking object in the scene. And you can actually go through that list and be like, why are 300 footprints all ticking? And it's because someone just left them on. Now, speaking of footprints, a good way to handle things like that is using this design pattern right here. It's a little tricky to read, but it says time minus time divided by effect duration and then saturated. Now, a saturate node means don't let the numbers go below 0 or above 1. It's just a clamp between 0 and 1. Now, the reason this design pattern is super powerful is that if you do something like, let's say you want to play a hit effect on a player's shield, you know, so it goes and like plays. Now, often that would be turning a value from 0 to 1, right? Now, a lot of folks would set that up in a timeline to say, you know, play the damage and then dial it back. But the truth is if you use a system like this, what I can do is I can read into the material current time as the start time, because the red node there represents time itself, which means time. Okay, if we want to play an effect right now, let's say we're 30 seconds into the game, okay? And we want to play an effect that flashes me for like 5 seconds, okay? That would mean that it would be 30 minus current time, so 30 minus 30, divided by 5 seconds. Is everyone still with me? Now, 30 minus 30 divided by 5 is 0, right? Because it's 0 divided by 5. Now, it means that 2.5 seconds in, when we hit like 32.5, that's now going to be 32.5 minus 30, which is 2.5, divided by 5, which is going to give me a value of 0.5. Do you get what I mean? So that's actually going to give me a really simple 0 to 1 effect without me having to constantly update that 0 to 1 value every single frame. It's a little thing, but I find this really, really powerful because now what I can do is I can, for instance, have all of my footprints fading out automatically without ticking, and then have my global manager just collect all of the footprints every now and then and either reuse them or destroy them. But it's all being calculated on the GPU automatically without having to be updated every single frame. And I find that quite useful. A really great console command that we have is stat dump hitches. So dump hitches will actually grab a value that you set through t.hitchFrameTime threshold. And if you actually hitch, like if your frame time goes below that threshold, it will actually report what was going on during that frame to say, hey, this was what caused that weird lag spike. And you can be like, yeah, great. So this is just a simple one, but you can right click on any folder and call set color. And when you call set color, it will actually allow you to just have different folders in your content browser set up with different colors. It's just nicer for organizing things and figuring out where stuff is, or potentially even like flagging certain folders as like soon to be deleted or something like that. The color picker is a really overlooked feature of Unreal. So if you look up top, whenever you drag a color into that bar at the top, it actually goes ahead and saves them. Like it allows you to create collections. And the cool thing is if I click on that little arrow, you can see that we can hit new, duplicate, or rename. And that allows you to really easily set up like the red team color scheme or the blue team color scheme. And because the color picker is used in every single instance of Unreal where you select a color, it now means regardless of whether you're in visual effects or the UI or you're in player materials, you can always access what those colors are in red team without you having to like just kind of eyeball it and hope the number is the correct one that was dictated by the art department at some point. Virtual cameras, these are really powerful. So you can actually stream Unreal Engine's screen through to your iPhone. And the cool thing is you can then stream the AR kit information from the phone back into Unreal and actually use that as a way of setting up the camera tracks. So you can actually look through your phone as if it was like a portal into the real world, and you can use that to just film a cutscene as it's taking place and then keep the whole cutscene's camera information. You can do multiple takes, you can cut between them, but it means that you can like really create that nice like shaky cam type of effect, something that doesn't look like a traditional, you know, indie video game cutscene that's often just that interpolation from one location to another. You can get something that just looks like it was kind of made by an actual cameraman, which is great. If you select any wire and you hold control and click on it, you can actually grab the wire and move it around. This is particularly useful when you have like 5 pins plugged into one blueprint node and you just want to grab all 5 at once. Next up is just promote to variable. So promote to variable is if you right click on any variable pin and you click promote to variable, it will just generate a variable of that type. This is really useful when something is like spitting out a variable and you can't be bothered really looking up if it's an object reference of a certain thing and blah, blah, blah. If it knows what it's giving you and you're just going to be saving that, just right-clicking in and promote to variable is just much better for your workflow. Now, it's worth noting that we have blueprint getters and setters. If you're coming from C#, this is pretty useful because you can actually go ahead and actually override with a blueprint setter these values. So these things here can then go ahead and anytime they get this value, you can do something else under the hood. Or anytime they set this value, you could go ahead and do something else under the hood for that one too. So it's really useful that, you know, if every time they set the current velocity, you might be clamping it or you might be updating a secondary function that's like being used as just a really quick lookup. Especially if you're doing like a square root function or something like that under the hood, it's kind of nice to just cache that variable out whenever it gets set. So being able to use blueprint getters and setters in that context is wonderful. So Gauntlet is a framework to essentially run things and validate results. Now this is really useful. We use this on Paragon, past tense, rip. But we use it in Fortnite as well. And what this actually does is it's a framework for deploying builds to devices and running tests and then collecting reports. So this means you can actually run every evening automatically without even doing anything. Just really basic tests and just say, is the game still loading? Are these levels still completable? Can these weapons still deal damage against these characters? Et cetera, et cetera. And we can do some pretty cool stuff here, right? Like you could run a replay every evening because Unreal's got replay support built in. If your game is networked, you can run replays, basically. So you could run that replay data on every device, right? And if you run that replay data on every device, and it hitches on one of them 5 seconds in, and it hitches on another one at the same time, it's really easy to scrub through the replay and see exactly what was going on from a user perspective at that exact point in time, which is really powerful. This is the procedural foliage tool. This is experimental, but we've used it in a lot of projects. I would highly recommend checking it out. To turn it on, you need to go to the experimental section of the editor and enable it. But essentially what it does is this. You can get all of your foliage in the engine and you can flag it as having growth rules. So I can say, look, this plant distributes this many seeds and those seeds can spread this far. This plant can grow in the shade. This plant can spawn and grow in the shade, you know. And I can set up anything that I want there. Now, the advantage in doing it is that when I click generate, it will then get all of the foliage that I just put inside of it, and it will generate an entire forest for me based on all of those growth rules. And this is just so much quicker than manually painting it out. Because the cool thing is that all of those meshes that it paints into the world are now accessible through the standard foliage painter tool. So you can like generate the forest and everything that you want in it, and then come back and then just touch it up yourself manually and clear out a couple of pathways and clear out some stuff around where the player is going to be and manually handle that area. But like generating the rest of it by hand is just often it's kind of a waste of time. And the truth is that by using a procedural rule set to grow those kind of things, quite often you can actually get a more realistic display than what an artist would have created, because it's actually following growth and distribution rules that are like putting them all in the right place naturally and clumping them together. And that's really powerful. So mask material in early ZPass, you can see this option here. You need to enable opaque and masked meshes in the early ZPass and then check that box. It's worth noting that this can have some serious performance boosts for foliage-based maps. Now, what it essentially does is it spends a little bit more time in that pre-pass to look at it to figure out which pixels should be rendered, right? And then it will correctly render your foliage so that if there's a ton of it that's overlapping, it's much friendlier. Now, the advantage in doing this is that I've literally seen a double teams outdoor frame rates for like products, right? But if you don't have a foliage-based environment, it does add a little bit of general overhead because it's calculating more stuff in that prepass. So it would make like an ArcViz demo a little bit more expensive. So you've really got to weigh up what your project's going to be dealing with and which of those situations is going to be better for your project. Make edit widget. This is just like a nice little thing that you can do. So if you see here, you can see that you can actually click show 3D widget on that little variable. And the advantage of clicking show 3D widget on that variable is that we'll actually give you like a little diamond that you can just move around. So if you actually declare a vector variable and it's going to be like, let's say you were making a jump pad, right? That jump pad I could actually set as like jump direction, and it will automatically create me a nice little 3D widget that I can just put in the right location, and it will then just, when the player hits it, jump in that direction. It's just much nicer for visualizing basic stuff. So A+, big fan. Next up is visualization modes. I touched on this one earlier. It's quite simple. You can just enable a simple a simple visualization mode that will show you every buffer at the same time. This is really powerful if you want to compare like roughness and metallic. If you have an object in your scene and you're trying to work out why it is sticking out when it shouldn't be and what's strange about it, go into this view mode because you'll suddenly notice that the roughnesses are different to every object in the scene. Perhaps the metallic values are different to everything else in the scene. And that's really, really powerful because you can really kind of narrow down what's causing those visual like artifacts without like necessarily fully knowing what's going on under the hood. You can just see what's wrong with the result and specifically which channel of the result to figure it out. This is what Alex mentioned earlier, which is you can select any assets or anything you've got and just paste it into Notepad. The cool thing here is you can modify stuff in Notepad and paste it back into the editor. This is really useful if someone is like, hey, I made a bunch of changes to the map and I accidentally moved this thing. Where was it? You can be like, here it is. And you can just copy and then paste the text into Slack or Discord or whatever your poison is. And like then they can just dump it right back into the engine. This is just a really simple workflow thing, but it's also one of those things that's clearly demonstrated by, because we use our tools, there's a lot of weird Slack stuff like this that we have to have. This is one that I wanted to flag, and that is that there are free automotive materials in the engine. So if you go to the marketplace, you can just download these. I believe these were done for the McLaren demo that we did a little while ago. But this is like really, really high quality car paint, carbon fiber, like rims, et cetera, et cetera. This is great stuff. And even if you're like, dude, I'm not making a racing game, that's fine. But you could still use it as a really firm point of reference for like how to make high quality paint materials and stuff like that, you know. Pulling from anything that's actually made from a AAA company is always much better than, in my opinion, than learning from stuff you bought from the marketplace. Because marketplace, you're never quite sure where it came from in terms of like, was this a solo dev that hasn't released a product, or is this someone that had years of experience? You kind of cross your fingers a little bit. So if you're using it to educate yourself, this can be a really powerful thing. And it's worth noting as well that like Epic did release Paragon assets too. Now, I think it was $17 million worth of Paragon assets were released for free when we released them after Paragon was kind of put to bed. Now, this is all the textures, the VFX, the animation cycles, and all the non-union dialogue. As well as that, we released one of the environments, which had 1,500 environmental assets created for 2 of the maps. So that's it's pretty powerful, and do recommend. This is kind of nice. You can flag either inside of a U property, so you can see there we're at clamp min 0, clamp max of 1. That'll just clamp that variable between those variables whenever it's set. The other thing you can do is just in Blueprint, you can click value range, and that will automatically change what the ranges are allowed to be inside of that. This is quite useful. You can do edit condition. So you can see that text down the bottom there says edit condition is equal to whatever. So in this situation, you can literally just make like a variable uneditable with the UI unless a few other checkboxes have been turned on. And that's really useful when like, if you have a lot of input variables that are only going to be useful in certain situations and you're giving this off to like a game designer or someone like that, it's good to just turn off the edit conditions when the booleans are turned off, because that way they don't change the numbers and can't work out why it's not doing anything, and that it's not doing anything because it wasn't turned on, you know. It's just one of those little things. Now before, this is really a programmer one, but before you saw Alex use that plus plus thing to do to iterate. So the reason that works is because you can use uparam to pass by reference. So you can pass a variable by reference in Blueprint in. However, I do generally suggest people be careful in doing so, because if you give it to someone who doesn't know what they're doing and they accidentally start passing values by reference that are being read in, you can have some strange effects sometimes. Like they start passing by reference all sorts of results, and it's a bit strange. If you hold V to enable vertex snapping, you can just more easily kind of snap assets together. It's much easier, especially when you're dealing with a grid, just kind of lining everything up and having a better time. The next thing is Pivot Painter 2. So this is a really powerful tool. So Epic actually released a bunch of 3ds Max and Maya scripts that are just in the engine folder of your builds. A lot of folks don't know that these exist, but you can open them up and do all sorts of crazy stuff. And what's great about this is like Pivot Painter 2 actually saves out the object hierarchy. So when I say it saves out the object hierarchy, you can then use that hierarchy to like dynamically grow the assets, to dynamically have the assets kind of like blowing in the wind, because the trunk won't move that much, but the branches will, and then the branches will, and then the leaves will move the most. And if you look at effect like this, you can see how using that world position offset combined with that baked out hierarchy allows you to generate some really wonderful effects. For any mobile developers out there, just a quick heads up, there is additional mobile functionality that is disabled by default. So all of the functionality that is disabled by default is it's all available in the plugins. So if you go edit plugins and then just type in the word mobile in the search, you'll find there's a bunch of just extra stuff you can turn on if you are making some mobile games in Unreal Engine. Now, Robo Recall is a game that we produced a little while ago. It was a AAA project that we developed alongside Oculus. I do strongly recommend checking this out. Now, even though you can't take things from it in the same way that you could something on the marketplace, it's still just a really good point of reference for, again, a shipped AAA. Shipped AAA somehow came out as Shipple. Being able to look at it like a shipped AAA project and what that actually looks like, all of the art optimizations that we did and all of the code optimizations that we did, it's a really good thing for you to explore and just learn from. I can't stress enough, there's a big fundamental difference between looking at a tech demo and looking at something that was actually shipped on products for everyone to use. And because of that, having this kind of resource is super powerful. Now, it's worth mentioning that one of the great things of that Robo Recall demo was actually behavior trees. So what happens is a lot of folks look at Robo Recall and they're like, I'm not making a VR game. Why would I care about that demo? And I'm like, that's cool. But that VR game has AI that are able to jump between bits of the world and find their way back into the world and do all sorts of crazy stuff, right? So why not just look at that part and understand it a little bit better? It's a real shipped implementation of behavior trees. And it's really, really great because you can see all of these advanced behaviors and how it was being done under the hood. And it's just an excellent resource to learn from. And these behavior trees tie directly into another feature that the engine has called EQS. Now, the environmental query system is really cool. What it actually does is you can see that orange player in the top, it's automatically scanning every player in the world, and it's saying what positions in the world can they currently see, and then it's rating every other position with a score based upon distance. Now, I used this yesterday, if anyone was in the session that I gave yesterday, and it's really powerful because you can really quickly say, what's the best hiding spot, or what's the best position for cover? I've seen it used outside of AI as well, and that's a really important factor too, because in the same way that you could look at every point in the world and say, look, what's the best place for this AI to move to, your game mode could use EQS to assess every single player in the world and their health, and then find the best position to deploy the super weapon that will make the game fairer. You know what I mean? You could use that same logic of just assessing, with really quick tasks that are getting shot out. You could really, really quickly and easily kind of go through that to find the best placement for dynamic spawned weapons, for respawning players so that, we don't spawn them, if they're blue team, we don't spawn them too close to red team, but they don't spawn in view of anyone on blue team, so it's still feels like they caught up and stuff like that. You could use it for all sorts of crazy stuff, and I do recommend it. Another quick tip is split screen support. The engine has split screen support just built into it. And this is really powerful because to add this to your game takes less than 15 seconds if you're just doing a quick test. You don't need to do any replication code or anything like that either because it's just local, right? So being able to like really quickly just spin up additional versions of the game and kind of have that split screen just working out of the box with no extra real effort, it's really, really great, especially for game jams. Like I remember one time I was at a game jam and they were working in Unreal and I was like, why didn't you add split screen? It seems like it'd be great. And they're like, oh, it was going to be too much effort. You know, we figured that we'd have to dive into, what are you doing? And I'm like, nothing. They're like, what did you do? And then I clicked play and the whole game was running in split screen. And it took less time than the explanation for why they didn't add split screen to their game to add split screen to their game. So it's kind of fun, right? I mean, it's a little bit show-offy when you do it, but also, you know, like if I'm building a game and I want to test something and it's literally one checkbox for me to see generally what it would feel like in a multiplayer environment, that's great. That is so good. And like it's so much fun for game jams to just be like, play with friends. So animation fastpath is a really important thing a lot of devs don't know about. It might be a little tricky to see there, but you'll notice we have lightning bolts over all of those nodes except for one. Now the reason we don't have a lightning bolt above that one node there is notice that unlike the other variables which are just unlike the other functions which are just accessing variables, that node is actually it's running a little bit of math first. It's multiplying both values by 0.5. Now, because it's doing that, it actually results in having to spin up the virtual machine, do that calculation, and pass it off. And that's not super slow, but it is reasonably slow when you've got a lot of characters. You know, you want to shave every bit of performance off that you can. So being able to like have that little lightning bolt is just a really quick way of saying this is a value that should have been calculated in the event graph, but instead you're calculating it in the anim graph. And if you had have done it in the event graph, it would just save it out and we could just access it and load it in and everything would be fine. But doing it here just adds that little bit of overhead. It's worth noting though that if that does worry you, you can check this value here that says warn about blueprint usage. And when you enable warn about blueprint usage, what it actually does is instead of just giving you a lightning bolt over the good ones, it gives you big yellow text and warnings under the bad ones. And this is, I actually recommend not turning this on when you first start your game. Turn this on a little bit into production because that way you've still got your iteration times up and you're able to figure out what the animation blueprint should look like and feel like. And then what happens is once you've got it playing nice and everything's good, enable this warning and go through and clean up all of the things that weren't being, like they were just being directly set like in the anim graph and setting them in the event graph instead. It's a reasonably quick thing to get clean and working, but my general advice is like use the system that allows for the fastest iteration up until the point that you're able to start doing a little bit of those optimizations. This is pretty straightforward, but it's pretty useful as well. In Unreal, you can reserve space in arrays and sets and anything like that. So you can actually just call, like in this case, we have a T array called locations, and we're calling just locations.reserve. And all we're doing is we're saying, hey, this is going to be this big. And that just means that instead of calling add each time, we're just like setting it. And that's just going to be much faster if you're going through a whole lot of array data, just like ahead of time being like, it's going to be this big. And it's like, all right, sick. Just generally, this is a nice little one. You can call declare stats group, and declare stats group actually allows you to set up your own custom stats group. So if you're trying to profile your own code and figure out why it's going slow and what's going on, this is just a really good, useful thing. Like if you've done let's say you've written your own combat system, right? You've got your own combat system with all sorts of attacks and all sorts of calculations going on. There's no harm in just setting up your own stats group that profiles your own code and says that, you know, this and this and this are currently costing this amount. And just really quickly being able to look at that as the project runs because it's super quick to declare. This is really useful. So I highly recommend that you consider using the forward renderer. Just consider using it. I'm not saying to definitely use it. But here's the thing, is for anyone that's unfamiliar with how game engines generally work, you've generally got two types of real-time setups, okay? You've got deferred renderers and forward renderers. Now, deferred renderers are excellent at running like a whole lot of lights, okay? But what they do is they essentially run through the scene and they use a thing called the G buffer to kind of like work out a lot of stuff to batch all that information together and then calculate it, right? It forms a big old texture and does all its calculations in one go. Now that means that they're super quick for handling scenes that we're going to have a ton of lights. However, caveat is that if you have a project that wasn't going to have a ton of like lights in it and you weren't going to make use of any deferred effects like screen space reflections or something like that, a forward render will often be much quicker. So a lot of people look at the forward renderer and they're like, oh, it's the VR renderer, and it's not. It's a forward renderer, which means like for some types of games, like if you're making a platformer or something like that, and you've only got minimal objects on screen anyway, again, like this can give you a pretty serious frame boost. But in addition to the frame boost, what it can also give you that's really great is MSAA. And MSAA is a much, in my opinion, I should say, it's a much nicer anti-aliasing format for certain kinds of projects. It gives much crisper lines than temporal anti-aliasing. You can clean TXAA up, but at the end of the day, it samples its previous frame to work out what the new frame is going to look like. And because of that, it does have some just inherent flaws. So as I said, like for certain kinds of projects, having MSAA is just really lovely. It's really powerful. So considering using that, not a bad idea. This is the lightweight rigid body simulation. This is really cool. So whenever you go to blow stuff up, you can actually call a function called immediate mode. And what immediate mode will do is it will now actually set it up so that, notice these characters when they're getting blown up, they're not actually hitting each other. Now, like the second I say it, you're like, oh yeah, they're not. But in a video game, you wouldn't really notice that. You know, like if explosions are raining down and bodies are flying up in the air and everything else, you're not going to notice. Because what immediate mode does is it runs the physics sims against only the static geometry, and that means that it's much more efficient and much quicker to have a whole lot of destruction and carnage happening if you're just running them in immediate mode, especially if you choose to only use immediate mode on explosions that happen in the distance. Up close, you can still have higher fidelity explosions, and then when they get into the distance, no one's going to notice that the two soldiers that were like yay big on the screen technically clipped with one another, so just do it. Yay. This is just a quick thing that's worth mentioning is we get a lot of developers that kind of coming in that they assume that everything in Unreal has to be done on the game thread. It's worth mentioning that you can spin up additional threads by using what's called the task graph. And the other really useful thing about spinning stuff up in the task graph is actually that you can kind of set up prerequisites too. So you could say, hey, look, spin up these threads, start doing the work, and on complete, once every thread is completed with its respective job, pass that information back, and the game thread can then do whatever it needs to do from there. And this is just really lovely because, like often you can get by with everything being in the game thread, but sometimes you can't. Now, the world composition tool is a pretty powerful little tool. This is something that we use for like large open worlds. What it essentially does there is that notice that each of those little grid cells, they all form their own little mini sub-level. And whenever you click on one, you can just load that level. And it means that as a player moves between the world themselves, they kind of seamlessly move between all of those levels, which is just really powerful because we can kind of stream levels in, stream levels out, just under the hood by just looking at what their position is, their XY position. And then like not only can we do that, but we can also just generate simplified static meshes of the levels that they're not in. So when they're away from that environment, it's just a really simple like one shot of what the landscape looks like from that distance. And then as you get closer, we switch in the correct thing. Now the next one here is pretty simple. Just in general, beware of overdraw. So if you look at those two effects, the one on the left and the one on the right, the thing is that left one, even the area that is black and 100% transparent, still has the full pixel cost of all of the areas that were white, okay? Because it's still calculating all of that information across every single pixel. Now what that means is sometimes, in fact quite often, splicing in a few additional vertices onto your particle is going to be much cheaper because you're not overlaying all of that transparency against itself, like again and again and again. You can use particle cutouts to just trim them right down. Now, fortunately, Unreal just has a setting called particle cutout, where you literally just read in a texture and you say, I want you to clip this thing down to this big. And the engine under the hood will just splice in the additional vertices necessary to do it. That's in both Cascade and Niagara. All right, this is a weird one, and you're going to need a pen to write this down. But if you want to view every single material's draw cost in the scene that you're currently looking at, you can run a command called r.rhicmd bypass. set it to 1, and then you can say, hey, I want to set the RHI thread.enable to 0, and then show material draw events to -1, and then run a profile. And you can't see it here, but that will actually give you the cost of every single material draw on screen, which is just really useful for getting the exact cost of some stuff that's going on. I know that's a really weird collection of commands, and make sure you set them all back to 0 to 1. Otherwise, you're going to have disabled your RHI thread, which is generally a performance boost. So material functions as layers. So if you look at these 3 characters, they all look pretty high def, right? And the thing is a lot of characters would, a lot of 3D artists would often spin up Quixel or spin up Substance, and they'd be like, I'm going to just output some 8K textures and make this character look good. And I'm like, don't do that. What's actually happening here is if we zoom in on him, you'll notice that Steel's got like that nice plating look up close. So we can still see that even up close, it's still got a really high fidelity. And the reason for that is what we're actually using under the hood is we're breaking up every section of that character's armor as its own submaterial. So you can see here that this one is the infiltrator's boot rubber. And we're reading in information for like tint, for scratch, for grime, for tiling, for roughness modulation, and grime brightness. And if we look at the actual textures for this character, you can see here that we have red, green, and blue all specifying different layers. So it's like this part of the armor is layer 1, this part of the armor is layer 2, and this part of the armor is layer 3. And if you think about it, you have 4 channels, right? You have R, G, B, and A, but more importantly, what you have is RGBA, and technically none of those layers is also a 5th channel. Do you know what I mean? So like you could use the absence of the other 4 channels as a 5th channel, so you could pack in a ton of things into one go. I find this really powerful. Now the second texture that you can see there, the one on the right, is a scratch, grime, and ambient occlusion mask. And the beauty of that is that if your mask has baked out the scratches, when this is saying that it's steel, the scratches will just go into that submaterial and scratch it to look like steel scratches. But if it's going into a plastic material, it would scratch it like it was plastic instead. And it would scratch it like it was any other thing. Now, the beauty of that is this. These characters can then all share the same base textures. And all we do is we swap out a really simple single material node that says, look, just switch your armor over to carbon fiber, switch the armor over to plastic, switch the armor over to metal, switch the armor over to anything you want. And like that's a really substantial time saver. Like here's the thing is creating one asset, not so bad, right? But if you want to create that one asset and have 10 different skins, that's expensive. Because you now need to have like all of that texture data for all of those things. So in theory, if you're able to share the same steel logic across every single character in your game that has steel at different points of their armor, you can massively, massively, massively reduce your overall texture pool size. And because of that, you can have higher quality textures because you're not fighting against all of the other textures for memory space. You know what I mean? Like I know I'm kind of like harping on this really hard, but like this fundamental design concept is super powerful. And we see a lot of devs who they'll make a one-time character that looks good, but if you were to ask them to make 10 characters, they would need to make 10 separate 4K textures for all of the diffuse, and if the roughness and like the metallic values were different, those would be additional textures stacked on top. And it just gets out of hand. So just consider this, and it's worth noting that as of Unreal Engine 4.24, we have gone back to developing an experimental material layer system, and that material layer system actually means that in material instances, you can just override the steel function and say it's carbon fiber now, or you could override the carbon fiber and say it's plastic now. So that means that you don't even need to modify the initial graph. You can just modify everything else going into it, and that, like, I know I'm a massive nerd when I say this, but like that's legit exciting to me. So like, don't judge me. But it's like that ability to easily produce a lot of content that looks good just adds so much value to your game. The next thing I wanted to mention was the stencil buffer. So the stencil buffer allows actors to be rendered in a separate buffer. Now, in this image, the buffer is being used to render an actor like through a portal as it emerges. Sorry, that's the next slide. So you can see here, the stencil buffer is being applied to this big meteorite, and it's now able to kind of like come out of that portal reasonably easily, and we can kind of just mask it out. And like this effect itself was like It took about 20 minutes in a hotel room, right? But it looks pretty good. And like being able to use those little types of tricks like that is like really, really powerful. A nice little feature that we have is called pixel depth offset. Now, pixel depth offset allows you to offset the depth of the pixel you're rendering. Who knew? So what that means is in a material, you can say to something, hey, instead of you being this deep, you're now this deep. So you're a little further away than you think you are. Now, you're probably like, what? Why would that have any use at all? Here's why. So remember before I mentioned TXAA, I mentioned temporal anti-aliasing. It blurs itself with the previous frame. Now, imagine this for a second. If we got an object and we said, hey, the pixel's here, and then we said, hey, the pixel's here, 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 and there was a surface in between the two, what's that going to do? If you're blurring them all together, I'll give you a hint. If I had a black card and a white card, like back to back, and I span them, what color would you see? You would see gray, right? And the reason you'd see gray is because your eye is naturally going to blur those two things together, and that's what's actually going on here. Both of those objects are actually fully opaque, all right? So both of those can completely be seen. However, as the thing touches the ground, it starts to blend itself with the ground beneath it. And that's pretty good. So next up is world-aligned materials. So if anyone's ever done triplanar mapping in like 3ds Max or Blender or Maya or Milkshape 3D, this is a same type of thing. You can just grab a single node and kind of drop it in. Now, that's reasonably obvious. You poke around the editor, you'll find that out pretty quick. What a lot of folks don't know is this one, and that is that we have a thing called pre-skinned local position, pre-skinned local normal, and pre-skinned local bounds. And now what these are, it means that every actor saves the position of all of its verts. Sorry, hiccups. Of all of its verts based upon its T-pose. So if you look at the left character, notice that the stuff is moving up and down. You can see that that's because it's the equivalent of projecting the character as it's moving through the world, right? However, the character on the right is actually being projected against its T-pose, and then it's moving it to the correct location. And by projecting it against its T-pose, you can now actually project like grunge and whatever. Like, if let's say you had a character that you had a plain white T-shirt, if you wanted to give them a camo pattern, like 50 different types of camo patterns, you could now run a triplanar projection against their shirt and just have that immediately applied, regardless of how the character moves around and warps. You could do the same thing for weapons, right? Like if I had a weapon and I wanted to project some sick-looking decal onto the side of it, I could do it. Not only could I do it, but I could easily, it means that when they pull out the magazine, the paint that was on the mag is now still painted in the correct location for the two things. And again, like that stuff to me is just like, that adds so much immediate value to some of your projects that I strongly recommend considering it. Now, the next one to go into is the sun position calculator. If anyone in the room here does any ArcViz projects, Unreal just has a plugin you can turn on that literally allows you to say what the longitude and latitude of the world is, which way north is, and what day and time of year it is, and it will just put the sun in the correct position based upon all of those rules, okay? And again, like this kind of stuff, like this is free. It's just a built-in plugin, but it's just turned off by default, right? Because most games don't need to know the exact location based upon the time and date. So mesh decals are really powerful. Mesh decals allow you to basically create a single material channel that automatically has decals projected onto it. If you're coming from Unity, you may not know what decals are. I'm under the understanding that that's not supported in the engine. Is that correct? Unity devs? No one wants to admit it. I see how it is. Okay, so what a decal is it projects something that you're looking through onto it. So you could easily project stains or normal alterations onto the material beneath you without having to have anything else. And you can use them normally by just dropping in a decal actor and it will project and look good. But mesh decals are actually like material channels of the actual mesh itself that will then project under it. Now the advantage of that is I could have 10 different pillars that all have the same underlying concrete that's just projecting those decals from different directions and different angles and immediately give me a ton of mesh variance using the same underlying concepts. And that's really wonderful. I went into this earlier today, which is auto LOD generation. So for anyone that's unfamiliar with it, Unreal Engine supports LOD generation. So you can literally just get your objects and say, look, you're level architecture or you're a prop. And you can set up all of the rules on that type of object, and the engine will literally just go through and generate all of the low poly versions for you and the distances in which those should blend in and apply them. Okay, this is, again, like I said this morning, there is no reason to have your artists kind of wasting away on that kind of work when you can put them like to using their skills to the max, right? Getting the most out of your artists is super important. And like, it doesn't just work for static geometry, you can do it for characters as well. And the character generate, oh, is that not playing? It is not playing. You can do it for characters as well. And when you do it for characters as well, all right, it looks like my PowerPoint presentation has decided it doesn't want to play. You're going to have to believe me, there's character loading. So what that means is we automatically can generate versions of this character that will look good, you know, at different distances away without having to have your artist spend all the time creating the 500 poly version and the 5,000 poly version and the 10,000 poly version. And the other great thing here as well is it's worth noting that you can flag as like, hey, whenever you deploy to mobile, you can tell the engine to just remove LOD 0 and fall back on LOD 1. So you can immediately have like the mobile friendly versions of the LODs just getting brought straight in. The cool thing is the engine actually cooks them out as well. So it doesn't even include any of the mesh data for LOD 0 on mobile if you tell it not to, which is like just a nice storage optimization you can do. I went into this earlier today, which is dithered LOD transitions, and that is that if you get a large scene like with a whole lot of foliage in it, quite often that foliage will pop as it switches between different LODs. There's just a checkbox in the engine that you can hit apply to, and now you'll notice that as I move forward and backwards, it's now going to smoothly just fade from one LOD to the other and just looks nicer. You just don't get that pop. It means that you can be more aggressive about how soon you actually bring LODs into the fold. You know what I mean? Like, because you're not as concerned about the fading, you can bring in those LODs a lot quicker, which has its own optimization. This is a useful one. So you saw Alex use an isValid node before. Oh, that is not coming through great. So an isValid node, seems like maybe all of my videos have stopped playing. All right. Give me one moment. I'm just going to hit escape and shift F5 and see if maybe it'll do it. Let's all just back away slowly and pretend that it was fine. So if you right click on a variable and click convert to validated get, it will still give you the get node that you already had. The difference is it will also give you two little output pins that say, hey, this variable's null, or hey, this variable exists. Is valid, is not valid. And that's just, it just cleans up your graphs a little bit. It means you don't have to have stuff going everywhere. I personally am a big fan of doing it this way. The next is drag and drop to fill arrays. So if you just select a bunch of stuff in the content browser, you can now, as of 4.23, I know this is a late feature, but you can now just drag all of those meshes like into an array on a blueprint and it'll just fill it. It's a little thing, but it's just nice. So here's a really cool feature that the engine has that a lot of folks are unaware of, which is called low latency frame syncing. So low latency frame syncing, it's kind of hard to explain, but essentially it works like this. If you can guarantee that your game is going to be running at 60 FPS, then what we can basically do, or any particular FPS, what we can do is we can grab the input slightly later in the frame than we normally would. Normally we would grab it really early on, but now we can grab it a little bit later. Now by grabbing it that little bit later, what that actually means is you get way more responsive input, because if the player hit a button after the input phase, they now would normally have to wait for the next frame for that input to be calculated and included, but now we can grab it later in the frame. What this means is if you're doing like a Street Fighter or a Tekken or something like that, like, you know, like a fast-paced combat game, here's the truth, is most people in the world won't notice the difference between frame syncing turned on and frame syncing turned off. However, if you want to make a beat 'em up or like a fighter game like that, their fan base will riot. So like having like as low latency as you possibly can is really, really powerful for those kinds of groups. What's worth mentioning though on that front that's really great is that sorry, not really great. What's really worth mentioning on that front that's really important, is that if you're telling the game that, hey, we're running at 60 FPS, so grab the input a bit later than normal, you do have an issue, which is if the engine is running below your intended frame rate. So if you've dipped a little bit lower, you run the chance of hitching because the input is now at the wrong spot and everything kind of gets out of line. So what you need to do is you use this when you guarantee you're going to be above a certain frame rate. You then say, look, this is the frame rate that we're running at. We're locking at that. We're putting VSync on and we're getting the inputs working really nicely through that. So you've just got to be aware that if you enable this, you need to really be able to guarantee the frame rate that you've set. High resolution screenshot tool. This is pretty simple. You can click on that little arrow in the top left-hand corner, and what it's going to do is you can then click on high resolution shot, and that just allows you to put out like a super high resolution image that'll just be kind of like tiled across a bunch of different images. It's just really good for pushing out like a 16K image of the screen or something, especially when you're doing events like this, right? Like if you were if you're exhibiting downstairs. Quite often you would want to have like a giant shot of your environment that looks really good that you're using for marketing materials. So why not just pull it straight out of the game at super high res and then down res it from there so that it's super sampled. Yay, everyone wins. Next one is F11. So F11 will go full screen on your, F11 will make the screen go full. But what a lot of folks don't know is Shift F11 will hide the start menu completely. So we'll actually kind of just get rid of that bottom little lip there. It's just, if someone's watching you work and you want to either enter hacker mode or you want them to not realize that you're running Reddit in background, Shift F11 is a good way to just quickly cover the screen and have anything you want there. Also, they'll be like, wow, they're so focused on their work, they can't see the start menu. Like, yes, that's why. So Unreal Engine, as of 4.23, supports a concept known as runtime virtual textures, and these are the best. So runtime virtual textures work like this. The first time you see a text cell, we basically cache it out. So imagine we were rendering your landscape, and you're painting on your dirt and your grime, and you're painting on your moss and your grass and whatever else, right? And like normally that might be like 600, 700, 800 instructions to have like all of that stuff there, okay? Now, what a runtime VT does is it essentially takes a photo of that specific text cell and it saves it out to a separate texture. And then the next time I see that piece of ground, it just loads it from memory instead of actually recalculating the entire stream again. Now, the real beauty in doing that is you can also, first off, you can cache it from any point along the materials chain. So if I'm rendering something to a virtual texture, I can say grab it from this point or before into the VT. But the other real use of that is because the VT information is being all calculated and saved out to a separate texture, other assets can look it up. So in this situation, what's actually going on is that tree is a separate mesh touching the landscape. And you can't see where the tree ends, so where the landscape ends and the tree begins, because the bottom of the tree is automatically blending into the same text cells, the same colors as the landscape itself beneath it. And it just merges the two things together. And it looks so much better and it's more efficient. So like, why would you not do that? The other really cool thing that's come in with RVTs in the new version of Unreal 4.24 is we now have support for height. So RVTs can save out the height of the world beneath it, which means any asset's material can say, how close am I to the landscape? And if I'm close to the landscape, start blending into the landscape's material. And it means that the second you put a boulder, no matter what direction it's facing on the ground, the bottom of the boulder that's touching the landscape will just immediately blend to match the landscape. And it's good. So format text, this is another one of those great things that's like a lot of folks just don't know about. So format text is a little node that if you add some stuff in braces, like if you type in any values in braces, it'll just create little input variables. And this is just really good for just creating your debug stuff because you can say, hey, it's this or it's this, and kind of set it up accordingly. It just makes life a little bit easier. Unreal Game Sync is really powerful. This is a front end for Perforce. So this is essentially, it's a really nice, does anyone in the room use Perforce for any of their projects already? All right, there's a few of you, sweet. So this is a front end for Perforce that actually allows you to have some slightly nicer management of your builds. Because what it will actually do is you can tie it into a feature known as build graph, and the engine can automatically just build binaries and then distribute those binaries zipped back to P4V, at which point, whenever an artist updates, it will automatically pull down the latest binaries for the build that they're updating to. So if they're like, hey, get me this version of the engine, it can then pull down the binaries relevant for the artist to actually just have that build of the engine. The other really cool thing there is it has like this great support for metadata. So you can actually retroactively go back and say, hey, this build broke, and add notes to specific commits and specific information. You could also tie your build server into that. So as your build server is running through and constantly building stuff, it could be like, wait, this one's broken, what happened? And then flag it as this is a broken build, broken by this thing. It's also got some other really nice stuff, like you can do things like you can flag each commit and say, you can check which user is currently on that revision. So just at a quick glance, it can be like, this person is using build 4.123, this one's on 4.123.1, and you can really easily see which commit everyone is currently up to, which is great when you're looking around the room and you're like, when did this break? Alex, is it broken on yours? I'm like, no, it's not. And you're like, sweet, sometime between these two then. Like it's a little thing, but it's quality of life, and this is the kind of stuff that really matters when you have a lot of people interacting with the system. Like you need just some slightly better like tools for that. And UGS is like, we have a bunch of tools like this and Gauntlet that we went through before. They're free. You can just pull them straight down and use them, even though it's technically not a part of Unreal Engine. Like Epic make royalty based on games, right? And because of that, like we're free otherwise. And because of that, it's 100% in our best interest that you succeed. Like it's very much a thing of like, there's no reason for us to not give away all of our plugins that we're using to bake stuff out and all of the subsystems like UGS that we're using. It's worth noting that in 4.2.4, we're even releasing a thing that ties into Unreal Game Sync called RoboMerge. And RoboMerge is a really, really powerful tool that we use internally, because what it does is this. If we've got a version of the game that's currently out, imagine that the next build beneath it is the next hotfix. And then the next build beneath that is the next major patch, and the next build beneath that is master. Now what that means is if you commit a change to the hotfix, RoboMerge will automatically grab that change and then implement it in every version beneath it. Which means if you fix something for the hotfix, every other version now has it. But like at the same time, if you change something in the next major patch, it'll only go through to the next major patch and master. And like this kind of workflow is just super important for, again, like managing games as a service especially. And this is like, it's these kind of things that are like really, really powerful for large teams engaging in these products. This is a nice little one for mobile. I'm a big fan of it in certain use cases. So you can actually depth project textures. We have a nice little function that's already created where what you can actually do is save out the shadow map from a certain direction and then run the texture as unlit, but you just bake the shadow directly in using a blueprint or something like that. And it means that it's not recalculating that shadow every single frame. And it also means that you can get some nice fake subsurface scattering on mobile for certain assets. It's a very sometimes thing, but players don't know that it's all fake, and it looks really good because of it and runs well. So this is a really important one for teams. I suggest you don't do it too early, especially if you're just learning how to use Unreal. You'll cause problems if you do. But if you've used Unreal for a little bit, go to your project settings and straight up just disable any permutations you're not using. So what happens is this, is when you build a material, we build a version of the material for a bunch of different conditions. So we'll build a version of the material that supports atmospheric fog. And we'll build another version of the material that supports the stationary skylight. And we'll build another version of the material that supports this, that, and the other, right? Now, here's the thing. If you're not going to ever have a stationary skylight because you're using like distance field ambient occlusion or something like that, so it's a mobile skylight, turn it off. Because now every single material will compile faster because you're not building another permutation for that specific variation, okay? Just nuke it. Now, the reason I said don't do it at the start is if you're trying to work out how Unreal works and you're turning off all of the features ahead of time, you're not going to know why it's broken when you have turned it off. You know what I mean? You'll be like, what's going on? And it's just like the option's not turned on, dude. So like you will definitely cause some confusion for some people if you turn these things off too early. You can, but just like be wary, right? So I kind of wanted to just flag that as a really important thing. Now, that text is super hard to read, so I'm just going to describe it. So essentially, a thing that is just generally a good optimization and a good habit to get into is remembering one very simple thing, which is that pixels aren't always the problem. A lot of people assume that the visuals on screen or the CPU are the only real two places that stuff can go wrong. But the truth is like your vertex shader, for instance, could be causing like a massive like slowdown in your game. So how do you determine if it's the vertex shader or the pixel shader? Really simple. Get the current image and write in r.screen percentage like 5. At which point the engine will drop the screen percentage down to ultra low res and just only render a couple of pixels. But here's the thing. If we render the screen at 5%, we're still rendering every single vertice at full, right? Because we still have to render every vert in the screen. Now, if the game is still running slow, and you didn't really see much of a difference between those two things, it tells you that it's not the pixel shader that's the problem, it's your tessellation, and it's your world position offsets, and it's those kind of things that are slowing you down. And that could be from any number of different things. That could be from like too many tries, it could be your view cost, it could be you use the level of detail meshes that you're currently using. It could be all sorts of things, but that's just a really good practice to get into if you're trying to diagnose why your game is running slow. This is something that Alex went into just before, which is just avoid hard references in Blueprint. So if you cast in Blueprint to another Blueprint, it loads the whole thing into memory. And if you cast to a C++ class, it doesn't load the whole thing into memory. So casting to native classes is always going to be better. The other thing there is if you're like, oh, but I don't have native classes, then just check if something implements an interface. That's always going to be quicker than checking against a blueprint. Now, the reason I bring this up is, let's say hypothetically you have a character that does a cast to the main menu of your game, okay? And then your main menu, for some reason, does casts to like every skin in your game that could be set up, right? Your main character is loading in the menu, which is loading in every single skin, which is loading in every single texture. Do you know where I'm coming from here? We just get this huge, terrible list of just things loading in things, loading in things, loading in things. And it was one blueprint node over here that caused the problem. So like making sure that you're really quite diligent on that is super important. And like it's one of those things that I always try and generally preach. Next up, we have plot function on graph. So plot function on graph is reasonably straightforward. It just allows you to get any function like dx, dy, and output it. So sorry, not dx, dy, f of x. So you can just get something and just plot it out and see what's going on. This is just really useful. If you're like, why is my contrast looking weird? I can then just plug in some values into that thing and examine it and be like, I screwed something up. This is useful in the editor preferences. You can enable a thing called small toolbars. So if you already know what all of those toolbar buttons do, you can get rid of the text and just have slightly more screen real estate and look like a pro. So A+ would recommend. This is something that I'm a big fan of. So in Niagara, we have a system known as interpolated spawning. Now, what this means is that if we were to spawn a particle now, and we were meant to have spawned 100 particles within the last couple of milliseconds, the engine will actually go back and say, hey, all right, so theoretically we're meant to have spawned this many since the last frame, so I'm going to spawn some here, some here, some here, some here, some here, and these ones are now up this high, because technically they're now going to be like 2 milliseconds old, and this one's going to be this high because it's like 1 millisecond old. Do you get what I mean? Like it retroactively works out where stuff should be, so that way if your game lags, the effects don't do something really weird. The problem is doing that actually adds a fair bit of overhead. Now, that fair bit of overhead is fine in most situations, but that is like 3 million particles recreating a dynamic holographic map. And the frame rate is completely different. When you've got 3 million particles and you're constantly retroactively working out where they should all be, just turn off interpolated spawning. If you're pretty confident in sustaining that frame rate, just nuke it, and you're going to be able to have like much higher quality, like higher density, I should say, effects. The VR editor, this is just one of those things that a lot of folks are unaware of. So you can enable VR mode and just edit the engine using, edit your levels and your world and your blueprints and your settings using VR. It's really great because you can then just modify settings while in VR without having to like put your headset on, take your headset off, put your headset on, take your headset off. You know, like that's just a really frustrating dynamic. So being able to like open up VR and like craft mountains, it's actually really cool because it ties into the landscape system. So you can be like, I'm just going to make a valley here. Like you scale yourself up to the size of a god and you're like, I'm just going to paint in some stuff, make some mountains. Yeah. And that's just good fun. Just a little thing is extending the editor. So just remember that most tools, like in modules and toolbars and stuff, have the ability to be extended to add your own functionality to them. And all you've got to do is look for the interfaces for has menu extensibility, has toolbar extensibility, and like look for any of the related delegates. And that's just a really useful little thing to set up. And with that said, we made it. We're through. So I know that was a lot of info, and we smashed through a lot of stuff. I saw some of you taking a ridiculous number of notes. Some of you looked like you were standing in front of a fan from like a 1980s metal video clip going, ah. But hopefully that was beneficial. And again, like feel free to reach out if you have any questions or concerns. That's my Twitter. Please only try and use the email in a situation that's like clearly relevant to email. Otherwise, my inbox gets full. I fly a lot. And if you're asking something that's like, hey, our business is doing this, and it's like obviously like stuff that you don't want to talk about in public, that's cool. Go for it, email away. But if you're like, hey, how do you do this effect? That's probably a better one for Twitter, because it also means that even if I don't answer, some of my other followers might jump in and give some advice and that kind of thing. So I hope this session was useful. I hope over the last 2 days, Epic's been able to provide a little bit of information for folks who are getting into Unreal. As I said earlier, and as Quentin announced yesterday, we are doing our best to kind of scale up in the region because, you know, it's in our best interest that we provide more workshops for people. Like we're talking advanced workshops and such, that we're able to provide just more sessions to get everyone on board, that we're able to start dropping into more businesses and offering advice and just doing what we can. So this is kind of really the first part of that. And I hope that over the last couple of days, you've started to see where these things are going, and this has all been useful. Thank you very much for your time.